Hello and welcome! Last time we made this altimeter, and this time we are going to hook it up to MobiFlight so it can work with the simulator. Let's go! So, this altimeter uses 3 motors, one for each hand, and then a potentiometer for the Colsman window. Let's start with these stepper motors. Each of these motors uses 4 DuPont connectors to go from ion 1 through ion 4, and then 2 male to female DuPont connectors to go from positive and negative. We're going to start off with one wire. There's a minus that goes to ground and a plus that goes to 5 volts. You can repeat that, and if you run out of grounds, which you will, or 5 volts rather, you can share. So you can just splice up a wire into this wire. So you could strip a little bit of this wire, attach it, and go to a different one. If you're struggling with this at all, refer to my how to wire a stepper motor video. The way you do it doesn't really matter as long as you assign the pins in MobiFlight to the pins you're using on the Arduino. Then plug it in and plug in the Arduino and you're on your way. The wiring for this is red on the top, white in the middle, and then it's black on the bottom. And then maybe cut off like a foot of it. Sorry, that's like a third of a meter. Then the red wire will go to positive, the white wire will go to AO, and the black wire will go to ground. To mount the Arduino to the instrument, we have this mounting plate right here. I put 4 10mm M3 spacers right here, and you can screw them down with nuts on the back to keep them in. Now we have these M3 20mm spacers, and you can put them out here. Then we're gonna screw these in and tap into the plastic. Now we have all of these that we wired up. Let's put them through here. Just unplug one and push it through, plug it back in, so that everything goes to where it came from. This version doesn't have enough holes, but I've exported this version that does have enough holes. So now we have all of these wires coming out of here, and then we have this black wire for ground for the potentiometer, this red wire, and this white wire. This can go over to the Arduino, and the Arduino can be mounted like so. The way I'm gonna ground all the grounds together and put the 5 volts together is by double crimping. There are other ways to do this too. You basically just need to touch the ground wire to all the grounds, and the 5 volt wire to all the 5 volts. But this is a way that doesn't require soldering. So, you know, there's always that. So we're going to take, let's say, 5 inches. 5 inches is 125 centimeters. So let's take, no, not 125 centimeters. Red and black. We're actually doing these separate. I'm just cutting them together so that they're the same length. Crimp off a little bit from each end. Maybe a little more than this. Strip off. Crimping is different. And then make another one of these. You can even use the last one as a length gauge. All of my long lengths are in inches and all of my short lengths are in millimeters, because I love working with millimeters to design stuff, but the world around me is in inches, so. We have our red wires and our black wires right here. We're gonna take, let's take the grounds first, and I'll show you what we can do. So I'm going to twist these together into one, we have our terminal right here. Put it in the crimping device. Push it through. If you don't know how to crimp, this is not the best tutorial to learn. So I'd go look at a few crimping videos first. Push it through. And then crimp it down. And last but not least, tighten it. Now you can see that this one terminal goes into 2 wires. We can do the same for this red, and it might take a little bit of practice to get it down. Twist this together. You could even crimp a little longer, and then make sure that no wire is exposed when the housing is put through. Today is National Side Snip Appreciation Day. Okay, we have these 2 wires. Let's put them into a housing. Give them a home. I'll put red on the right, because like R is like the letter that kind of sounds like it should work. R, right, red, starboard. Wait, is starboard right or left? Okay, and here we have it. Make sure that no wire is showing here. And the smaller the wires, the easier this is to do, but of course you do want to be able to supply the current of the motors, so don't go too small. But I would just get something with a smaller insulator. Or get a bigger terminal. And the hardest part for me is making it click. So we have these 2 motors in the middle, and then this last one we can set to just crimp normally. So now you plug red into positive, 5 volts, and then black into ground. Plug negative into black, positive into red. Do the same for all of these. This can get messy, so make sure to double, triple, and maybe even quadruple check your wiring. Oh, I love misquoting things. As the ancient Chinese proverb says, make sure to empty your recycling bin often to maintain good computer hygiene. But make sure, and the hole right here, you should screw through, and everything should go through. Make sure it's not so tight that it's hard to rotate the wheel. That's what we in the industry call a bad day. On to MobiFlight. I'd like to address the elephant in the room. I changed my background. Okay, so we're going to create 3 stepper motors. We did the ready, fire, aim approach, where we just put in 4 random wires, put in another 4, put in another 4.
Did you know the Cessna 172 is the most produced airplane in the world? Did you know that the clouds are actually made of cotton candy?
Let's start off by opening up MobiFlight modules and adding 3 devices, actually 4. 3 stepper motors, 1, and it autofills the first available pins, which I've used, 2 through 5. Add another, and add another. I'm going to name them in a second once I know what they do. Yeah, we're going to use full step classic. This will be slow. We could also use, for the minutes hand, is it called minutes? I guess it'd be seconds. For the hundreds of feet hands. For the hundreds needle, we're going to actually use the half step mode, so it's faster. Okay, we have our 3 stepper motors using pins 2 through 5, 6 through 9, and 10 through 13. We're also going to add a device, analog input, and this will be the Kolsman window. And let's update it. Yep. And go to output. We're going to make just a test event to see what motor does what. Alright. Display. Stepper. And this is the first stepper we have. Alright, so this is the 10,000 foot. We can zero this. Set 0. And move on to the next one. Write this down on our iPad. So now we can write 1 is 10,000. And if you can read it, then even better. Let's try the second one. That is the thousands place. Alright. 2. This is 1,000. Sorry, what is 1,000? And 3 is hundreds. We can test it right here. 1, 2, 3 should be hundreds. Oh my gosh, this one is going the wrong way! It's actually going the right way. The other ones are going the wrong way because of the way gears work. It swapped the direction when you gear it up, when you add a gear. And since we added a gear, we'll have to unadd it in software. So now we can go into MobiFlight modules and we can rename these. That was actually a coincidence. They were all in order. 10,000, 10,000, 1,000, 100. Alright. Now, upload the config so we have all our names. Make sure that 100 is in half step mode. And now, let's start with our hundreds needle. So, under sim variable, let's take the altimeter setting, or the altimeter altitude. Search up altitude here, and boy do we have a lot of altitude stuff. Let's change the aircraft to generic. And now, we still have a lot, so you can never win. But we search through here, we should see something indicated altitude right here. So indicated altitude right here, this will just read the altitude, which is what we want, okay? Let's go to compare. We don't need anything right here. Display. Now, it should say 100. Should have a display scale of 1,000. Test value should be... Ta-da! It goes 1,000. And if you need to, you can tweak this full revolution motion. And that'll do you well. Compass mode should not be enabled. But should it? We'll get there. We'll get there in a second. So now, sim variable. This is hundreds of feet. So let's click run. Now, if we click run, we'll notice it's going backwards. Usually that's not the way altitude works. If you're at sea level, you can't go down. So we need to make this negative because the stepper motor is going negative because of the gears we mentioned earlier. Now, if we go here and click run, it goes the correct way, and it'll make 1 loop, 2 loops, 3 loops, 4 loops, and it'll make 4.214 rotations. So much. The entire reason I designed this with 3 motors is so that you can control the hands individually, and instead of going, you can just go like that. Yeah. So what we're going to do is use the %. So this % sign, it kind of acts like a remainder. So we have $% %1,000. 1000. So this gives you, let's even put this in parentheses right here, $%1000 will give you the remainder of if we divided this by 1000, which is 214. You can see it going back over here to that same 214. Ready? Come on. Come on. There we go. Now if we click stop, it returns to 0. And if we click run, it goes right to 214 feet. Let's duplicate this row, duplicate it, and go to thousands needle. Now, click edit, go to sim variable, indicated altitude, but this time we want the remainder after 10,000 because it's the thousands needle. It has 1,000, 2,000, 3,000, all the way to 10,000. So 10,000 is the point where where you need to divide it by to get the remainder of 10,000. So now if I click run, first of all, the motor will freak out because it's being manipulated twice. And also, oh, yes, it is most definitely freaking out. Let's disable both of these real quick. Okay, just to see the numbers. Our altitude is 4,214 right now. The 4,000s, yeah, we're good. Okay, brain fart. The brain fart has been air freshened. Okay, so this 10,000s needle right here shows the 4,000 it's responsible for. That's in between 0,000 and 10,000, that 4,000. If it was at 44,000, it would still just snap to that 4,000 because it only cares about things between 0,000 and 10,000, and it takes the remainder and puts it at 4,000. So this is the formula. It's the same one as last time, we just added a 0, and we will have to divide this in a second to make it be able to be displayed, because if we say display scale is 10,000, it's gonna get mad at us, or 100,000 in the future. Really? Yeah, 100,000 for the next needle isn't allowed. We're gonna keep the display scale at 1,000. And then to make this, and because this display scale, this should be 10,000, is from 0 to 10,000. Since this is from 0 to 1,000, we need to divide this by 1,000 so that it fits inside the 0 to 1,000 stepper acceptance rate place. Basically, the stepper motor reads a value from 0 to 1,000 and displays that on its scale thing. And what we need to do is take that 1,000 and fit this value, which the maximum is 10,000, into that 0 to 1,000 range. So we're just going to divide it by 10 right here. When we click run, it's 412. It's 421. So that fits into our place. Let's activate both of these. Click edit, and under display, make sure this is set to 1,000. Okay, make sure to set the 0 for your stepper so that all the needles are at 0, and then click OK. And when we press run, I forgot that some of them are. We did copy over from our equation this negative, and since this is geared, that negative shouldn't be there. So make sure to remove that so that the needle goes to where it should go. Okay. Just so you know, when you assemble it, run these tests to make sure that the needles don't conflict. They will fight each other sometimes, so you'll need to make sure the way you assemble the gears doesn't make conflicts. Okay, so now we have the thousands needle working. We click run. The thousands needle is at 4. The hundreds needle is at 2. Or 214. And now we just have the 10,000 needle. duplicate row, 10,000 thousands needle right here. Stop it before angry things happen. It might be too late, honestly. Now, sim variable. We'll do the exact same thing, except for this is 10 times smaller steps and 10 times bigger number we need to ignore. So we go over here. This is 100,000 right here. If I made that a year, I'd be doing pretty good. 0,000, 10,000, 10,000, 10,000, all the way to 10,000, which is 100,000. And then this divide by 100 is to get that 100,000 into the 0 to 1,000 range. We're going to go to the 10,000 needle. Display scale is 1,000. If we click OK and now run. Why is it backwards? No clue why it's backwards. What I'm going to do is make a negative right in front of this $sign, and that'll put it forwards where it's supposed to be. Oh, there's a keyboard shortcut. Windows left arrow. Aha, Windows right arrow. Okay, now if we look at the altimeter, it matches up. I'm sure I have an altitude button here somewhere. Oh, that's nice. At least I have that. I've got to have a tool somewhere that gives me altitude. Why can't the up button just make me go up? No, I want more ice. Okay, I'm like Elsa. I think I found the go up button. It's right here. Zoom, zoom, zoom. Let it go. Let it go. Hey, the altitude is basically where my altitude is. Let's go. Ready, pause. Yeah. It looks like, okay, 20, 40, 60, 80. Okay, yeah, that checks out. Ours is probably closer to 90. Not gonna lie, if we click stop, I'm pretty sure it's just because our 0 is off. So we can adjust the hundreds needle 0, click OK, save it, run it. Right now it's at 180, or 4,380. We have a condition that we don't want to happen. Right here. You saw it, the motor goes backwards. Why is that? That's kind of dumb. And then it catches it, and if it goes back to 0, it hits 0 and goes all the way back to 9. And it hits it again. Why is that? What's happening? That's crazy. What's happening is it's going 999, 1,000, and then it has to go all the way back to 0, and then continue to 1, 2, 3. So that is what's happening. The way to fix that is using compass mode. Now we can go under hundreds needle, click edit, and you'll have to do these for all of the motors. Click compass mode, and instead of 999, 1,000, 1, 2, 3, it'll go 999, 1,000, 1,001, 1,002, and we can see that right here. Ready? If we go down, it'll just smoothly transition. Zoom. If we go back up, and mind my flying, I lost about 500 feet in a matter of seconds. If we go here, ready, moment of truth, and it just continues. So that is the fix for the problem. Just make sure to do this on all 3. I have no clue what my speed is. Speed is kind of irrelevant anyways. You don't even need to know your speed to fly, basically. Next time we'll be building the attitude indicator. That's going to probably be a very sassy video. I'm going to be making way too many attitude jokes. If the background's different, that's because I moved, so yeah. Can't live in the dorms forever. You don't want to live in the dorms forever. Trust me. Alright, now we have the motors all working. Let's get this little knob working. So, on the altimeter, we twisted this knob all the way left to its 0 position, and this knob right here affects the motor. You can see right here, turning this knob turns the number card. It's as if I designed it that way. Now I'll just turn this, and you'll see right here, once we screw in a screw, it'll mount with the 10-turn potentiometer. So what we want to do is get to the lowest attainable setting, so that's 27.9 on this card. And you can't miss it. You can't go back because that'll turn the potentiometer. So 27.9 is right there. Now I'm going to screw this in. 2 points. My 0 for some reason traveled all the way over here, and that must have been because I moved the potentiometer and the shaft while I was doing it. So your value for the 0 of the potentiometer might be a little bit different, so just keep that in mind while you're configuring yours. Alright, let's head over to MobiFlight. We plugged in the Arduino, plugged in all of our systems. All systems, A-OK. If anyone knows what that's from, let me know in the comments. The first one who's right gets a satisfaction of winning. Alright, so under Altimeter for Flight Sim 2020, we're going to go under Inputs. And remember, we have our Colsman window potentiometer, pin 0. We're going to make a variable. Colsman. Really hope that's how you spell it. Click Edit, and let's go over to our Arduino. This is the old way of doing it. I use the old way, but scan for input, and then just twist this. Ah, pretty cool. Alright, now under action type, we're going to say MobiFlight variable and value at. So we're going to say my var is altimeter underscore adjust. So that is just what I'm naming my variable. And if we read our variable right now, click edit. We're in the inputs outputs tab now because we want to read the value. We can go to MobiFlight variable, select it right here. The simulator isn't, if we click run, the simulator doesn't even have to be running. It is, but this just reads our potentiometer setting. So the minimum value we're going to say is practical, 27.9. Gives us a value of 19. Now this is going to be the really hard part for some of you, some of the younger people. We're going to get a pen and paper, and you just write that number down. For the younger generation, I do have an adaptation for you. Here you go. 19 right here. We have 19 is the lowest potentiometer value. Oh, I don't want altitude right now. Go away. And then that corresponds to 27.9er. Another thing under MobiFlight modules, we're going to have this as, we're going to boost the sensitivity. I wouldn't put it at high or 1. I'm going to put it at 2 or maybe 3. High will just constantly bug the simulator and it'll decrease performance. We can go under logging to click debug right there. So sensitivity, let's say 2. Click OK. And now you, because we enabled debug, you can see whenever we twist this, it can it detects a change. But if we have it at 1, it'll give us a good amount of noise. Yeah, right here it's ticking between 17 and 18. So we'll just set sensitivity to 2. That way it's precise, but not noisy. Okay, and let's go back to 27.9. This gives us a value of 17. I misread it as 19 because the sensitivity was too high. Let's twist all the way to our point we care about, 29.902. So that's 29.902 gives us a value of 71. We know that right here. So 71 29.902. And now, if we go all the way to our max is 31.5. That's the maximum number that we can get to. I feel stupid now because I made an effort to use a 10-turn potentiometer, and we're using one of the turns. So you can get away with using a 4-turn potentiometer or one or 2-turn potentiometer. This classic potentiometer we usually use isn't a full turn, so you can't use this. I might factor this into a redesign, maybe, but only time will tell. For now, we're going to use the 10-turn potentiometer. And so our range goes from 110, and that corresponds to 31.5. So now we have our little table right here. Usually I write this on paper, but you know, you can see it's kind of fun, kind of spicy. We have 19, which corresponds to a value of 27.9. So we're going to go into the compare tab and apply an interpolation table. So this basically stretches the values to go into, it basically stretches a line of best fit to your data, given a few points. So let's use our lowest value, 19, with our output value, 27.9. Let's go 27.9 right here. And then over here we'll go 71, shoots out a value of 29.902. And one more row, 110, shoots out a value of 31.5. All right. Now, if we go to 29.902, it gives us a value of 30. So, why is that happening? I don't know. Actually, I do, because I've done this. The value of 30 right here, these output values, unfortunately, these only support giving out a output value that's rounded. So, sorry, you gotta deal with that. In fact, it even has a weird rounding error when you put them in just normally. But we can get around this rounding to the nearest whole number issue by rounding to the nearest whole number we want. So 27.90 becomes, once you multiply it by 100, 2790. 29.92 becomes 2,992, and then 31.5 becomes 315. No, it doesn't. 3,150. Now, once we click OK, 29.902 is 2992. And to add the decimal, we divide it later in a second. Hold your horses. So we have sim variable. This reads our thing we have from the input. We have our compare. This basically has our 19, our values here. Under display, this is where the magic happens. So you go to output device, and instead of an output like we normally do, it's going to be an input. Okay, so on press and on release is really nice for flashing lights and stuff. I can show you that in a future video that I probably may or may not make. And then on change, right here is what we want. So whenever this value changes, you can see me playing with it right here. Whenever this changes, we want to go to the new value. So on change, we're going to go to Microsoft Flight Simulator 2020, and we're going to search for men. I spelled it right. Let's go. Okay, and then we're going to search under generic. So there's the Colesman decrease, increase, set millibars, and set inches of hydrogen, mercury. Why is mercury Hg? That makes no sense. It's Greek or something. I don't know. So we're going to select Colesman. Is that spelled right? Yeah. Colesman set in inches of mercury. For set to any number in inches of mercury, replace the at with your desired setting. So if we look here, if we wanted to just set it to 2.9.902 and then click run, it's always set to 2.9.902. There is a rounding error. If you squint really hard, it says 2.9.902. I think it might be a unit conversion error, but that sets it to 2.9.902 if you don't trust me. And this decimal place shouldn't matter. Like, you can't detect it that far. The computer can store it to however many decimals it has. I can assure you, though, the most seasoned pilots can't detect a difference 10 to the negative 15th of an inch. Not even a machinist. That's it's a lot of, that's less than 1,000th of an inch. So yeah, chill out, be calm. Okay, now let's go over here. And all of my, oh, this is the wrong one. Right here is set to that value. And what we had originally right here is this @ sign. And that @ sign reads this value that gets put out here. But uh-oh, that value is multiplied by 100. How do we divide it by 100? I don't know. I don't even know at all. What we can do right here is we have this number, and we can replace it with this number. Basically, just move the decimal point down a little bit. Man, whoever wrote this preset did a really good job. No one's clapping. Okay, so yeah, we have this value right here, and voila. Now it sets to 2895, and we read our value right here, 289505424499511172. And if we twist our knob, it lands where it's supposed to. So this says 2829, this says 2829, and we're at 2829 right there. Now if we tune to a random heading, not a heading, but 30.1 gives us a value of 30.1. And yeah, let's go. Woo, woo, woo. Okay, let's click run and see what our altimeter does. So we are at our setting of 30.0. Let's change it. Let's go 29.5. Does the altimeter match? Yep, it still does. That's awesome. Now is a great time to get your instrument rating. If you're having trouble with the 100-foot needle, you can switch it from the half-step mode, which is weaker, to the classic full-step mode. That will make it slower, but you can go over to the hundreds of needle, reset, reset, reset. That'll make it about half as fast. Okay. But if you click run, it should stay on the position closer. Now let's continue flying around. Yep, and where we are right now, the altimeter matches our simulator. So I would call that a win. Always look on the bright side and keep the greasy side down. Now that we've successfully landed our plane, there's only one thing left to do. That's go get a meal. And a perfect place to do that is today's sponsor. This video is sponsored by Factor. When you sign up for Factor, you get fresh, ready-made meals delivered to your doorstep. Factor's chef-created meals are fresh, never frozen, and designed by dietitians. No more meal prep, no more dishes, no more unhealthy fast food. Factor offers the most convenient way to eat well while eating right. Factor's menus are updated weekly and include more than 27 meals and more than 34 add-on options. Choose your favorite meals or let Factor craft your order based on your taste preferences and meal history. Factor saves time and alleviates stress. Feels these days stress is everywhere, but convenient meals are almost nowhere. Factor helps meals come together in minutes instead of hours, days, or even years if you're that bad at meal prep. Factor even makes it really easy to follow keto, low-calorie, vegan, and vegetarian lifestyles. Use my link or go to go.factor75.com and use code FACTOR-SE36067 for 50% off your first box.